Actually, some issue happening, so please wait. Please have some patience. They are working on it. If you have any questions, you can ask. Meanwhile, I can answer. I am good. It's not visible on YouTube. Yeah. Please have give some time.
Yeah, when you actually it is sorted, you can start the session. I share the link with Prajwal for the internal people.
What link? I didn't get you. I mean, it's not.
Yeah, I'm sharing the link. Wait. For the internal people.
But
The
student,
YouTube link.
what link? I didn't get you. I mean, it's not.
Yeah, I'm sharing the link. Wait. Hello. Yes, Venu, everything is sorted. You can start. I think you are on mute. Venu, you are on mute.
Yeah. Sorry. Okay. Thanks. Okay. Yeah. Good evening, friends. So sorry for the delay. Some technical issue has happened. I hope now it is resolved. Okay. So without delay, we'll start the class. I'll share my screen. So I hope you all can see my screen. Just confirm here. Confirm in. Okay. Good. Right. So I'd welcome to this session on Masterclass on stacks and queues. Right. So before I start, I'd like to give introduction about myself. So I am Venu Gopal Panchumarthi, working as a senior curriculum engineer at Masai school, and I did my BTech in computer science from IIIT Nojveed, and I did my masters in information security from Hyderabad Central University. Then I cleared my gate with 95.6 percentile, and I qualified for both assistant professor as well as JRF. Right. Okay. And before joining to Masai, I worked as a software development engineer at EA Sports, and I have mentored close to 5,000 plus students, and I have a 5+ years of teaching experience. Right. So I hope you all know. Yes. No. Cool. So now we'll start directly the topic, that is stacks. Right. Okay, so we should understand proper formal definition of a stack. See, many people will say, if I ask what is the stack, they will say stack is a data structure or which will work on last in first out model. Like that they'll say, friends. But in interview, if they ask, right, you need to say the proper definition. right? Okay, now let us see what is the proper and exact definition of a stack. So stack is an abstract data type. Now I'll tell you what is meant by abstract data type. So stack is an abstract data type that serves as a collection of elements with two main operations, and those operations are includes, one is push operation, second is a pop operation. So basically push operation adds an element to that collection. Pop operation will remove the element recently added, which we haven't removed yet. Okay, so this is the proper definition of a stack. And now next it comes the order in which that elements are added in the last in first out manner or first in last out manner, right? So this is the proper definition of a stack. Now we should understand, what is meant by abstract data type. What is meant by abstract data type? Okay, so now let's first understand this ADT, very famous term in the computer science, right? So we do have inbuilt data types. Now if you take any programming language, let's say C, C++ or Java, we have something like a inbuilt data types, that is int, or let's say float, or something like char. Basically these are our system defined data types, friends, or inbuilt data types, which means they comes with the operating system. Right now, using these data types, we can apply some operations. For example, if you have two integers, let's say, so we can add two integers, we can do the subtraction, or we can do the multiplication. Like there are some standard operations we can perform using these inbuilt data types. So this is also called as a inbuilt data types. Inbuilt data types. Okay, but what if I want to perform my own operations? Let's say, so these are the inbuilt data type, and we can perform some predefined operations. But if I want to perform my own operations, right? So using these data types, whatever the data types that I have mentioned, using all those data types, we can create our own data structure. Using all these inbuilt data types, we can create our own data structures. On top of those data structures, we can apply some user operations. Okay, so basically this ADT definition is a data structures that we can build using the predefined data types, and on top of that we can apply your own user defined operations, friends. That is called as an abstract data type. Now our stack is also an abstract data type where we will define some operations. Now let's see what are all those operations. Okay, first, so now if you see here, I have listed all the operations that we can perform on a stack. So usually the stack is going to looks like this. So this is how generally stacks will looks like, and all the elements are going to add it like this. So for example, let's say if I want to add 10, then if I want to add 20, and if I want to add 30, like that, all these elements are going to be added in this manner. Okay, now first operation is full operation. So this operation is going to return either true or false. So either true or false it is going to return. For example, if the stack is full, so we have always limited stack, friends. So always we are having a limited stack or some fixed size stack. We have some certain fixed size stack. Okay, so let's say if you want to assume stack is full, on top of that, if you want to add any new element, then of course it is going to return false. Similarly, there is one more operation called as is empty. Okay, again, is empty also is going to return either true or false. In case if the stack is empty, right, then it will return true. If the stack is not empty, then it will return false. Okay, so is empty will return true if stack is empty. Otherwise, it will return false. Next operation that is having is peek. Now the peek operation will always return topmost element of a stack. Topmost element of a stack. Topmost element of a stack, it is going to return peek operation. For example, now let's say you have added 10, then 20, then 30. Now, if you call peek on this stack, for example, let's say this is ST. Now, on top of this stack, if you call this peek operation, then it is going to return output as 30 because it is the topmost element. Next operation that we are having is push operation. So push operation, it will add an element to the stack. So it will add that element to stack. Okay, stack ST. Now pop operation will delete. Pop operation basically will delete an element from a stack. These are the basic operations. Okay. Now the most important point you should know, when you are doing push operation, when you are doing push operation, you should supposed to check for whether stack is full or not. So if stack is full, then still if you are trying to push some other elements, of course, it is going to give a overflow error. Overflow error, because stack is limited, fixed size. Completely stack is full, and still if you try to want to enter add a new element, of course it gives a overflow error. Similarly, when you do the delete operation, so when you do the delete operation, we should supposed to check is empty or not. In case if stack is empty, then you can't delete any element. When is empty true, what does it mean? No elements in the stack. If there are no elements, then what you will delete in the stack? Nothing, na? Therefore, always when you do the push operation, you should check for the overflow condition. When you are deleting any element, you should always check for the underflow condition. Underflow condition means if there are no elements in the stack, and still if you want to delete some elements, then in such case, it raises a underflow error. Next, it is a overflow error. These are the basic terminologies. Okay, this is the basic terminology. Okay, cool. Now I have listed some of the operations. Now see here, consider a stack of size of 5 elements and assume initially stack is empty and apply the following operations on a stack. Now they are clearly mentioning in the question, the stack size is 5. So which means at any point of time, you can store only 5 elements at max. 1, 2, 3, 4, 5. So maximum 5 elements you can store. Let me call this is stack ST. Now they are applying some operations, friends. Okay. So first push 10. So directly 10 will be pushed into the stack. Next push 20. So 20 will be added to the stack. Then 30. So 30 will be added here. Okay. Now when you do the pop operation, okay, the element which you will get is 30. So this 30 will be deleted from the stack and it will be written 30. Next, you are trying to add a push 40. So when you add 40, it will be placed here, friends. It won't place here because empty space is there now, because already element got deleted, right? Now here, the element 40 will be added here. 40 will be added. Next element is 50. So therefore, now next element will be added will be 50. The next pop operation. For this pop operation, 50 will be comes out. So this pop operation expected output will be 50 and this 50 will be gone from the stack, right? Okay. Now next they are adding 60. Okay. So this 60 will be coming here. Next they are adding 70. 70 will be coming here. Okay. Now let's say if I do the 10th operation, for example, in the 10th operation, if I add push, let's say 80, for example, if I do the push 80, then what is the output it will come? It will give the overflow error. So it gives the overflow error, friends. Why? Stack is full now, correct? Because there is no element to add there. Therefore, it will give the overflow error. That's why whenever if you are doing push operation, it is always advised to check the overflow condition. Overflow condition. Okay, cool. Right now, pop that element will be gone. So this is how basically stack operations will work. Right. So now you need to know how actually internally it is getting implemented, because these all are user defined functions, right? We defined actually push, pop, we define, friends. Now how it is internally getting implemented. So they will take 1D array. So 1D array they will take and they'll use a top pointer. So for the push operation, initially top will be pointing here. So they will increment the top and they will add that element, right? That is how it will work. But again, I'm not going in detail, friends. Just so since I need to cover so many topics, so I'm not going in detail these things, right? Okay. Now, but this is an overview of the basic stack operations. Okay. Next, similarly, queue is also there. How stack? Like what are all the operations that are present on the stack? One is full, is empty, peak operation, push operation, pop operation. Similarly, we do have a queue data structure. Again, the same definition, queues also. So queue is a abstract data type. Again, friends, this is also an abstract data type that serves as a collection of elements with two main operations. What are those two main operations? First one is enqueue operation. Second one is the dequeue operation. In enqueue operations, which adds element to its collection. So one by one collection in a first in, first out manner. So in FIFO manner, element are going to get added. It is normal queue only. Let's say if you want to take a train ticket, so usually we go and stand in a queue, na? Same only here also. Next, the order in which that element are added or removed from a, it is not a stack, it is a queue. So queue is described as, so this is not a stack. So queue is described as a first in, first out. First in, first out. Okay. Now again, we'll take some examples so you'll get more clarity. So now usually, so we have seen operations on the stack. Similarly, let us see the operations on the queue as well. Okay. So first, as usual, is full. So before you want to add an element, you need to check, is there any space in the queue or not? So again, queue is also limited. So what is meant by limited? It is a fixed size. So fixed size. Fixed size. Okay. Is full. Again, it written true or false, depends on the condition. Next, again, is empty. It is also written either true or false. Okay. Next, special operation called as a front operation. Like what does this front operation does? So it returns the, top, not topmost element, the first element to get deleted. So it is always written beginning element of a queue, friends. So this front will return the beginning element of a queue. Beginning element of a queue. Next, enqueue, so which we usually add an element. So adds to queue. Similarly, dequeue operation means remove an element from a queue. So remove an element from a queue. So if you see here, front operation, if you call now, it just return the beginning element of a queue without deleting from a queue. This is most important. Without deleting an element from a queue. That is important. Okay. Without deleting an element from queue. Whereas if you see the dequeue operation, it will remove that element from the queue. Most important things. Okay. Now let's see some operations. Okay. So consider a queue with the size of 5 elements. So assume initially queue is empty and the following operations are applied on a queue. Okay. So let me take queue like this. Okay. So queue will have two sections. One is entry section and another is having as a exit section. Exit section. Okay. At max, only 5 elements can present in a queue. That is the meaning of it. Okay. So first element I am doing enqueue. So element will come. So first 10 will enter and it will go standard here. First element you have added 10. So capacity of the queue is 5. Capacity will be 5 friends. Okay. Next I am doing enqueue. In short, I have written enqueue. Okay. Next element is 20. So 20 will be added here. Next I am doing enqueue 30. So 30 will be added in the queue. At max, only 5 elements can present. Okay. Next dequeue. Now if I call this dequeue operation, so who entered into the first? That will come out first, friends. Now if you see in this queue, 10 is in the beginning. Therefore, if you call this dequeue operation, you will get output as 10. Now this fellow will be now no more in the queue. This fellow is now no more in the queue. Okay. Next I am calling enqueue 40. So now next 40 will go and stand at here. Okay. It is entry and this is an exit. Okay. Next you are calling enqueue 50. So then 50 will be coming here. 50 will be coming here. Next you are calling dequeue. Now when you call this dequeue operation, next who will be deleted? Next who will be deleted? Because now see, first already 10 is there, 10 is gone. Now next fellow is 20. So this dequeue, you will get output as 20. Okay. So next you are calling enqueue of 60, which means this fellow 60 is going standard in front of queue. Now if you see, now queue is full. Because I told, no, this 20 gone already. Okay, this 20 is now no more, right? Next enqueue 60, yes, then when you call enqueue 70 also go and stand in the queue. So next time if you call the dequeue, 30 will be coming out. So that is how the property of a queue works. So first in, first out manner. Now these are the basic things with respect to stacks and queues, friends. Right? So very simple things that we have seen. So first we have seen the stack and all its operations we have seen: is full, is empty, peak, push, pop. Then we have seen queue. Okay. So and what are all the operations that queue is doing? See, because these we are going to use it in the subsequent slides, right? Therefore, I have shown. Next. Now, the first and foremost important question with respect to interviews. So the first question is implement a stack using queues. Okay. Implement a stack using queues, which means now you have to implement the stack. See, implement the stack, it means, so stack is containing two main operations. One is push operation. Okay. Second is pop operation. These two operations you have to implement, but you have to use queues. Okay. And we know what are all the operations that we can apply it on the queue. What are all operations we can do on the queue? You can do either NQ operation. So you can do either NQ operation or you can do the DQ operation. So which means you can use any number of NQ or any number of DQ operations you can use, but you have to implement a push. Similarly, pop also you have to implement. Inside, you can use any number of NQ operations and any number of DQ operations you can use, not a problem. But you need to implement push and pop so that we can call it as it is a implementation of a stack. Right. Now, let us see how it will work. Okay. So as I said, we need to implement a stack now. So therefore, let us take only stack operations because we have to implement a stack. So when I say you have to implement a stack, you need to write only stack operations, push, pop only. Right. So we know how the stack looks like. So here I have taken one stack. One stack I have taken, friends. Okay. Now, since we need to implement using queues now, therefore I will take a queue here. Okay. So let me call this is as a stack yes. Okay. And I will call this is as a queue. Okay. Okay. So here this push operation add an element to the stack. Right. Now I have to write it using NQ and DQ. Now what I will do is, so normal push operation in a stack, I will consider it as a NQ operation of a queue. NQ operation of a queue, and let's see whether it will give proper result or not. Okay. Cool. So first I'm going to add 10, right? So I have added 10 to the stack. Now this is entry and this is exit. This is exit, right? Okay. Now what I told, normal push operation in the stack, I am assuming that is equivalent to a normal NQ operation of a queue. Then what will happen? This 10 will be coming here and this 10 will be going there. Okay. It is entered into the queue. Next operation is push 20. Okay. So I will add 20 also to the stack. Then this 20 will go and stand beside this. Next is push 30. So 30 will be added here and that 30 will go and stand beside this here. Next element is pop. Okay. Now if I do the pop operation, normally what is the expected output? 30, right? So if you do the pop operation, the expected output will be 30. But if I assume this pop operation as a normal DQ operation of a queue, if I assume like that, then my expected output is 10. My expected output is 10, which is wrong now. You have to get 30. Correct? But it is giving 10. Therefore, it is wrong, friends. So if you assume normal push operation as a NQ and normal pop operation as a DQ, then it is wrong. Okay. Now, obviously, we have to take one more queue. Just with the help of one queue, we cannot do this. So now what we will do? So let me call this is Q1. Q1 I will call and I will take one more queue. Okay. So I will take one more queue. This is Q1. So entry and exit. Let me take same queue one more time. So I thought that with one queue, we can't able to do this. Then let me take one more queue, that is Q2. Okay, I have taken one more queue called as Q. Okay, now let us see with the two queues, can we able to do it or not? So with the two queues, can we able to do it or not? Okay. So a simple algorithm is there, friends, to solve this question. So let me write it on the left hand side. Let me write it on the left hand side, or else I'll directly show the code and I'll explain here because this algorithm is already present here. So see here, very simple algorithm. We have already seen that two queues we need to take. So let me take this is Q1 and let me take this is another queue called Q2. Okay. So see here carefully. Q1 and Q2. Okay. Because we need to implement a stack. So this is entry and this is exit. Similarly, entry and this is exit. See, very important question. Please listen, okay? So I have taken two queues. Again, this is not related to any particular programming language. So since here many students are there from different kind programming language backgrounds, that's why I have taken only algorithm, friends. Now from algorithm, you can easily implement whichever language you are comfortable, right? So this is just an algorithm. Okay. Now I have taken two queues, Q1 and Q2, to be a global queues. So global queue means it can be accessible anywhere in your program. That is the meaning of global queue. Okay. So first now I have to implement push operation and pop operation. First, let's talk about push operation. So here, this I'm going to call it as a X. Okay. So this function push is taking X. See, these are all user-defined operations, friends. So user-defined one, right? Okay. Now, first push operation of 3 steps. First step, Q2.enqueue, which means in the Q2, they are saying add the first element 10. Okay. Now I'm going to add. So in the Q2, entry and exit. So which means first I'm going to add an element to Q2. That is the first step. Now, second step, while Q1 is empty. This is called Q1 is empty. But before that, if you see, I have kept a not symbol, which means Q1 is not empty. If that is true, then execute these two statements. If that is not true, then don't execute this, because when while loop will execute, if that condition becomes true. Now, if you check here, is my Q1 is not empty? No, my Q1 is empty. Therefore, for the first element, this while loop condition will fail. So it will directly execute the third step. In third step, what I'm doing, if you see here, so what is this operation, friends? What this operation tells? Swapping the contents of Q1 comma Q2. You are basically swapping. You are swapping Q1 and Q2. Q1 and Q2. You are swapping these two. Then what will happen? Whatever that elements that are present inside that Q2 will goes here. Okay. Or in simple words, if you want to say, this Q1 will be coming here and that Q2 will be going there. Or this 10 will be present here only. Just the names will get interchanged. That's it. Okay. Which means now this will become Q1 and this will become Q2. Okay. That's it, friends. Next. So one element is over. First push operation is completed. Okay. Next push operation. Next element that I am doing as 20. Again, what is the steps that I have written here? First, Q2.enqueue, which means inside Q2, we are adding an element X. Now, what is X right now? 20. Now, this time, this is Q2. Okay. Now, 20 will be added here. Okay. Very good. Next, what is the second step? As long as your Q1 is not empty, you delete an element from Q1 and add it to Q2. Okay. Now, is my Q1 is not empty? Yes, one element is there. Then delete this element from Q1 and add that element to Q2. Then what will happen? This 10 will be get deleted from here and is going to add it to Q2. Next, is my Q1 is not empty? No, this time my Q1 is empty. So as long as your Q1 is not empty, delete all the elements one by one and put it to Q2. That is what the second step is doing. Okay. Now, when your Q1 becomes empty, all elements will be gone, friends. This condition also gone. Next, we are swapping contents of Q1 comma Q2. So contents here won't get swapped, right? So Q1 name will be pointing here and Q2 will be pointing here. That's it. Q2 will be pointing here. Okay. Now this time, this is Q1 and this is Q2. Next, third step operation, that is push 30. Again, first add an element to Q2. Now this is Q2. So this element 30 will be added here. What is the second step? As long as your Q1 is not empty, delete one by one and add it to Q2. So delete one by one and add it to Q2. Delete one by one and add it to the Q2. Okay. Now if you see, after deleting these two elements, now Q1 becomes empty. Then this while condition will fail. Next is swap the contents of Q1 and Q2, which means all this will go to Q1. Rather than sending all this to Q1, you simply change their names. So this will be Q1 and this will be Q2. Now all the contents are getting swapped, right? So this is also done. Now 3 operations are completed. Now if you see, now if I call this pop operation, As per that previously, the expected output is 30. But now let's see whether it is giving 30 or not. Now, where is your 30 is present? 30 is present here, friends. Therefore, if you see the pop operation, I will directly call return q1 dot dq. So if I call q1 dot dq, this 30 will be coming out. In fact, same 30 we are also expected. 30. Simple one line operation. Pop operation is just one line operation. Okay. Next operation is again pop. Now again pop, directly you can return q1 dot dq. So delete this element and you can just return here. Yes, very good. Next operation is push 40. Now see friends, these two elements are gone from the stack. Now no more, right? Okay. Now next deleted element is going to be 10 because it is on the exit, right? So it will move forward. So this is the next deleted element 10. Okay. But meanwhile, we had one more push operation, that is push 40. Again, push operation is this code. First, you add an element to Q2. So Q2, first we are going to add that element 40. Okay. Then delete an element one by one from the Q1 and add it to the Q2. Okay. This is also done. Now no more elements present inside the Q1. Right. Next, swap the contents of Q1 and Q2, which means in the Q1, you should get 10 and 40. So rather than sending these two elements here, you simply put Q1 here, right? And you simply put Q2 here. So that now my Q1 is containing 10, 40 and Q2 is containing a empty. Next, push 50. Okay, next 50. First you add it to the Q2. After adding it to Q2, so delete an elements one by one from Q1. One by one you delete, right? And then swap the contents of Q1 and Q2. Then, okay, these will be gone. So now Q1 will be coming and Q2 will be going above. So this is Q2, right? And this is Q1. Now, next, if I call the pop operation, the expected output will be Q1.tq, right? Q1.tq, then 50. So basically, this is how the algorithm will work, friends. So I hope everyone understood. Right? So this is how actually the algorithm will work. Very beautiful algorithm, right? Okay, now in an interview they can ask, you can say this pseudo code also, but if they ask you to implement, of course, from this algorithm you can implement in the language which you are comfortable. So if you are in Java, you can straight away declare two queues, you can straight away implement. If you are from JavaScript, same like that. Okay, so you can implement it, friends, right? Okay, now after applying all these operations, what is the resultant contents? In Q1 40, then 10. In Q2 empty. Okay, so this is how we implement a stack using queues. Now similarly, you need to check implement a queue using stacks also. We need to check. Second question, this is the first question, implementing a stack using queues. Now let us see implementing a queue using stacks, right? So this is the second question, implementing a queue using a stack. Okay, now they're asking you to implement a queue. So we know already queue is taking only FIFO order. So this is entry and this is exit. Let me call this is queue. Now first you are going to add 10. So 10 will be added, then 20, then 30. Now if I call this DQ operation, what is the expected output for this DQ? Whoever comes first, that will come 10. Next DQ operation expected output will be 20. Next I am adding 40. So 40 will be added, right? Next NQ I am adding 50. Next DQ expected output will be 30. Right. This is what the expected outputs, friends, as per the proper queue. But they are asking you have to use stacks. You should not use queue. But if I use a stack, let us see what will be the output. If I take only one simple stack, if I take only one simple stack, let's say yes. Okay. Now first I'm going to NQ, I'm considering it as a normal push, 10, then 20, then 30. Now if I call DQ as a normal pop, so it gives output as 30. But that is not I am expecting. I am expecting 10. But can I get 10? No, it is not possible, friends. You cannot get this value 10 because stack will work as a LIFO order, last in first out order. So whichever the element is on top of the stack, for that element only you are having an access. This element you can't access. Okay. Don't say that I can return S of 0. No, that is wrong. If you are returning S of 0, then it is not a stack. Please be careful about here. right? Okay, then just in one stack we can't able to do. Then how to solve? So we came to know just in one stack we can't able to solve this. Then how to do? Then of course you should go and take one more stack. One more stack. Okay, so here I have shown an algorithm for the two stacks. So let me copy all these operations and I'll explain this algorithm. Okay. So I can explain quickly. That's why I have taken the code in advance, right? So let S1 and S2 be two global stacks. Okay. Let me take two stacks here. Let me take stack S1 and let me take another stack S2. So two stacks I have taken. So one I'm going to call it as S1. Second, I'm going to call it as S2. S2. Now see, I'll see the algorithm carefully. So let S1 and S2 be two global stacks. Again, what is meant by global? So you can access anywhere in your program. That is the definition of a global stack. Okay. First. Now, first operation is NQ. So this is, let me call this is as a X. Now, when they're asking the NQ 10, so this is X. Now, if I adding 10, then I am NQ operation, I am adding an element to the S1. So which means first 10 will be added here. Next element X NQ 20. So again, for function NQ, always add an element to the stack S1. Then I'm going to add a 20 to the stack S1. Next, another NQ, which is 30. So NQ is straight away, you take that element and you add that element to the stack S1. Next is important one, that is DQ operation. The normal expected output is what? DQ 10. But if you do normal delete, normal pop, you will get 30. But that is not what I'm expecting, right? So then, but how should I get this 10? So delete an element one by one and add it to the S2. So that 30 will be coming. On top of the 20 will be coming, on top of the 10 will be coming, and the 10 you can take and return. Okay. Now see carefully the function DQ. How I wrote a function DQ. So first of all, they are checking is S2 is empty or not. So stack S2, for example, if it is empty, okay, stack S2 is empty, and inside S1 is also empty. Then what does it mean, friends? You are applying to DQ operation. Okay. First, you check that S2 is empty, let's say, and assume S1 is also empty, which means no elements in the queues. Whether you take this element or here, no elements. Still, if you are trying to apply DQ operation, it should supposed to raise a underflow error because no elements, right? If S2 is empty and S1 is also empty, and if there is nothing to delete, then you should return, of course, underflow error. But here S1 is not empty. Then what they are doing? So now here, this if condition will be false because now my S1 is not empty, friends. Then what they are doing? Delete one by one element from S1 and add it to S2. Now see this while loop carefully. While as long as your S1 is not empty, see, I have kept a negation symbol here. Negation symbol. Okay. As long as S1 is not empty, then remove an element from S1 and add that element into the S2. So the removed element will be stored inside the temp, and the temp, whatever that element present, that I am adding it to the S2, which means delete an element one by one from S2, okay, and add it to S2. So delete one by one from S2 and add it to S2. One by one element from S1 and add it to the S2. Okay. So I have deleted all the elements from the stack S1. Now the moment when stack S1 becomes empty, loop is going to be failed. Right? Okay. Now if you check after this while condition done, now finally I have written S2 dot pop. So whatever that element on top of the stack S2 is going to be returned. So that is 10. Now this 10 will be no more in the stack, and same expected output also 10. Okay. Next to DQ operation is there. Normally, what is the next to DQ? So in a queue, if 10 gone means next expecting is 20. Now let us see, is our algorithm is also giving 20 or not. Now again, when I call next to DQ operation, control will comes here. Now I am checking. Now see carefully. Now is my stack is empty right now S2? No, right now my S2 is not empty, friends. Some elements are already present. When you have already some elements, then you can straight away return that element as a resultant of a DQ. Right? If my S2 is not empty, which means my S2 is empty. But if this stack is not containing any elements, then only you bring an element from S1 to S2. Otherwise, you no need to bring anything. Simple. Okay. Now when S2 is not empty, okay, so straight away you can return that element which is 20. Therefore, expected is also 20. 20. Okay. Next operation is NQ 40. NQ is very simple. You directly add that element into S1. Okay. Next to NQ 50. So NQ directly add that element to the S1. Okay. Next is DQ. Next operation is DQ operation. Okay. Now what DQ operation is says, if S2 is not empty, okay, if S2 is empty, it failed, but S2 is now not empty. It's not empty. It's an element is there. Then this condition will fail. You straight away return that element which is present on top of the 30 stack S2. In fact, 30 is the required output here. 30. Therefore, now this element will be gone. Now, next, if one more pop operation is there, just as an our interesting. Okay, this is not pop. So here, if another DQ operation is there, then now stack becomes empty. Now you bring all the elements one by one here. So let me do. These already gone. These are now they are no more in the stack. Now when you do the DQ, now my S2 is empty. When your S2 is empty, you take one by one and you put it to the S2. Okay. Then you return the topmost element, that is 40 as the answer. Yes, this DQ 40 is the expected output. Right. So this is how this algorithm will work, friends. Somebody is saying it's a beautiful algorithm. Yes, yes. It's a very beautiful algorithm. Very simple, friends. Someone, sir, thank you, sir. It was confusing when learning in unit 3. More details. Yeah, thank you. Thank you, Sharma. Okay, very simple algorithm, friends. Right. So, but my concern is you should not get confused between previous one and this one. Okay, the previous one is implementing a stack using queues. Okay. Now this algorithm is also known as. So here what we have done, we made, when you are implementing a stack means implement either push or pop. So here if you see, we made push operation more costly. Here we have made push operation more costly. Costly means it's taking more time compared to pop. But maybe you can try with pop operation as more costly also. It's really interesting exercise. So you can come up with another algorithm where pop operation will take more time compared to push. Maybe you can try. It's an interesting exercise also. Next, second. Now here if you say we made DQ operation as more costly. We have made DQ operation as costly. Again, in the same problem, maybe you can make NQ more costly compared to DQ. Again, it's also good exercise. You can try, right? So these are the two most important problems at every beginner, those who are learning stack, they should know, friends. Right? Okay. Now we'll take one more question and we'll take some break, small break we will take. So that's up. So I hope these two problems are clear. So people who are in the Zoom, please confirm. So please confirm. Is it clear, friends? Okay. Is my speed all okay? Awesome. Okay. Thanks. Thank you. Right. Oh, crystal clear. Very good. Very good. Right, friends. Now let's go to the next question. That is a very, very famous question. Very, very important question. You name a company, this question will be there. And in fact, this question is getting used as in a practical way also. In practically also, this question is getting used, friends. In compilers, especially, this question is getting used in a compilers. First, let's understand what is this problem saying. Let's understand what this problem. So the name balancer parenthesis problem says, so if they given any expression, so here parenthesis means total three parentheses. 3 will be there, friends. So first one will be like normal bracket, open bracket and closed bracket. And second we are having is flower bracket. Next we are having is a square bracket. Total we are having 3 different parentheses are there. So first is open bracket and closed bracket, normal one, then flower open, flower closed, then square open and square closed. These are the 3 different parentheses that we are having. Now, if an expression is a combination of any of these, so total 6 are there, 3 open, 3 closed. Total here we are having 6 parentheses are there. Now, if any expression is a combination of these 6, if I want to say that expression as a balanced, it should satisfy two conditions. Again, I'm repeating, if any expression is a combination of any one of these 6 parentheses is called to be a balanced, then it should satisfy two conditions. What are all those two conditions? Now let us see. So the first condition and the second condition. First condition would be, the number of open brackets should equal to number of closed brackets. The number of open brackets should equal to number of closed brackets. So how many number of open brackets are there? Those should be equal to number of closed brackets. Open, and this is closed, friends. Closed. Number of open brackets should equal to number of closed brackets. That is the first point. Second point should be, second is order should be maintained. Second is order should be maintained. What is meant by order should be maintained? Okay, so let me take some examples. Okay, so I'll take some examples here. We will see whether they are balanced or not. So first example, let's say I have opened one, I have closed, then open, this is closed, closed, open. Now tell me, is it balanced? So first condition, open bracket should be equal to the closed brackets. So here open brackets are 1, 2, 3 open and 3 closed. Okay, no problem. First condition is satisfied. What about second condition? Order should be maintained, which means order means if you have any open bracket, listen my statements carefully. If you have any open bracket, right, before corresponding closed bracket comes, any other open bracket is there, it must be closed. Now, as what I exactly meaning is, now here one open bracket is there. Now correspondent closed bracket is present here. Okay, correspondent closed bracket will be present here. In between, there should not having any unopened bracket, or just like one open bracket should not be there. Okay, so I'll take more examples. This will be more clear. So let's say second, first one open, let's say closed, now open, let's say open, and now tell me friends, is it balanced? Is it balanced? No, it is not balanced. Why? First of all, here itself it is failing the definition. How many open or how many closed? For example, if I take one more bracket here, number of open and number of closed are equal, because if you see 1, 2, 3 open and 3 closed. Okay, this condition is true. But the second condition, if you see open, closed, no problem. Between nothing is there. Open, corresponding closed, and this is unclosed one, because this is you are closing where after this you are closing. You have to close here. You are closing after that, right? So this will be false, right? So one more example we'll take. So let me take one more example. Is it balanced? Is it balanced? See, first of all, how many open and how many closed? 1, 2, 1, 2, 3 open and 3 closed. Open, closed, no problem. But you open, and where you are closing, you are. But meanwhile, there should not be any unclosed one, because here you are not closing properly. You have to close, but you are not closing here. Therefore, it is not balanced, right? So these are the few examples to check whether it is a balanced one or not, friends. Okay, now let us, very simple algorithm is there. So now let me explain what that algorithm to check whether given expression is balanced or not. Okay, right. So maybe I will take this expression is in form of an array. I'll take this expression in form of an array. So I have taken one character array. 1, 2, 3, 4, 5, 6. Okay, I have taken only 6, right? So, and the order elements are, let's say, open, closed, closed. Okay, so assume this expression is a string X, string yes. Okay. Now tell me what is the output I should suppose to return? What should the output I should return? True or false? True, friends. If it is balanced, we should return true. So output, what is expecting is either true if it is balanced, or else you need to return false. Okay. Since this expression, so number of elements are 6, total 6 characters are there, and the output that it is expecting is true. True, because it is a balanced one. Okay. So how we can solve this with the help of a stack? Very simple. So left hand side, I will write an algorithm. So here I will write an algorithm. So function, let me increase the size. Function is balanced. Okay. So it will take yes and size n. Okay. So yes is nothing but an expression array. Okay. So I am going to take first let st is equal to, I have taken one stack, friends. So assume it's a stba stack of characters. Again, I'm writing algorithm only, not code. It is not related to any programming language. So it is just assume a stack. Okay. Normal kind of algorithm this is. Okay. Now, first I'm going to take one stack yes here. So I have taken stack yes, and the name of this stack is st. So the name of this stack is st. Okay. So now you can take one loop which is starting from the first character. So yes of I. Okay. If you see any open bracket. So what I meant by open bracket, if you see any open bracket, that is either this or this or this. If you see any one of these, you simply push that element into the stack. You no need to do anything. If you see an open bracket, you simply add that element to the stack. Okay, so what I mean to say here. So for I'm going to take one loop I starting from 0. Okay, and it is go till last element and then I plus plus, right? So now what I'm checking is, in case if s of I is equal to, just give me a minute. So whether it is this one or yes, or we do one thing. Maybe we can store it into some variable and then we can take that. Okay. So here I will take input or take some variable temp. Okay. So temp is equal to, I will take s of I. Okay. I'm just storing inside that variable temp, friends. Now I will compare. Okay. Or else I'll take input. Okay. Now I'll compare. If our input is, which means this element. Okay. So let me take element. Okay. So our element is, let's say, either open bracket or our element is equal to you have using directly s of I also, not an issue, but just I'm storing into an element. If that element would have been, let's say, open parenthesis, if that is either open parenthesis or logical or operator. Okay. Our element is equal to, let's say, this is completed. This next remaining is this one, open square bracket. Okay. If you see any one of these, so what you just do, you simply add that element, friends. You simply add that element to the stack. Nothing. You don't need to do anything. If in case if that element is not any one of the open bracket. Okay. So whatever that element is, let's say, is not of open bracket, then what you should supposed to do. Okay. So first we let us take, when I is equal to 0, it is an open bracket. Therefore, let's simply add our open bracket. Next, I will be incremented. This is also open bracket. You simply add it. Okay. Next is, see carefully, friends. Now it is most important thing. So open brackets we have added. Now if you see, our input is, or our input element is a closed bracket. So if it is a closed bracket, what we need to do? Very simple. If input is your closed bracket, then remove the one element from the stack. So if your input is a closed bracket, so I said open bracket, what to do? Now, what if our input is a closed one? If your input is a closed one, so first you remove the topmost element from a stack, remove top of the stack. Second, check whether check for matching. Check for matching. Like, what does it mean? Now, since now our input is a closed one, okay, then remove one element. Now check for the matching. Now, is they are matching? Yes. If they are matching, continue. So when you are checking for the matching, you will get two things, friends. Yes or no. If it is yes, you can continue. When you are checking, let's say if it is yes, then continue. Go for the next element. In case if it is not matching, our checking in case if gives true, no. Checking means for this, let us say if this is this, then you can stop. Then you can stop and you can say it is not balanced. Okay. Now let us see else. Else. So what we'll take? We'll take the top element. Like, so I have taken one element, maybe let's say top element. Okay. So top element will contain, I'm going to pop it. So first what I'm doing, you see, when this else condition will be true, in case if our input is not a open bracket. If so else condition will true in case if it is a closed bracket. If it is a closed bracket, remove the topmost element from a stack. After removing, now I am going to check. What I am going to check, see carefully, friends. If top element is equal to, let's say top element will always be open bracket, friends. Top element will always be an open bracket because all open brackets only we are pushing into the stack, right? If top element is equal to, for example, let's say this open bracket, just as an assume that it can be either this or this or this. It can be any one of these three. For example, if your top element is equal to this open bracket and your input is equal to, let's say, your input is equal to any one of these, except this, any one of these, then you can stop it. Then you can stop it and you can say, yes, it is a not balanced one. Okay, I hope you are getting. So what I'm doing, I'm removing an element from a stack and I'm checking for the comparison. Correct? Okay, so now same thing, I'm going to write it here. Okay, so top, if this would have been the top element, right? And your input is, let's say, your input is equal to if your input is, let's say, this one, or for example, if your top element is, let's say, it's not take this much name, you take simply top, just take the name of top. Okay, here top element is always open bracket only, because only open things only basically we are pushing. And if your top is equal to open, but your input is either this or let's write it in a different way. If your top is equal to this and your element is equal to, let's say, this. If this condition true, or your top is equal to this and your element is equal to this, then what does this mean? Tell me. Then what does it meaning, friends? If top is means open bracket. If top is this and let's say your element is, for example, square bracket, or your element is either this one, then what does it mean? Mismatch, right? You can return false. You can stop the process and you can return false. Correct? Next, for example, just give me a minute. or rather than writing like this, maybe in both of the cases, top is common. If you check here, friends, top is common. You can take top as a common separately. We can even do like that also. What I'm saying is, so for example, if your top is, or if your element is, let's say, first we'll if your element is, let's say, open bracket, for example. If your element is open bracket, and if your element is a open bracket, right? Just give me a minute. Just need some space. Okay. So else we have came here, right? So this element I have taken, yeah, element. Now we are comparing. So this element, let's change it to not this much big name. So I have taken a character, which is equal to. Okay. So your character, your input character is, let's say, open. You have always pushed that element into the stack. So if your input character is open, then push into stack. Done. Now else means your input is open bracket. Your input is a open bracket. Correct now. So if it is input is a closed bracket. Input is a closed bracket. Now let us see here what to do. Now this will be no confusion. Now it will be no confusion, right? If it open, you have pushed into stack. In case if your input is closed one, then I'm going to take one variable called as top and st.pop. I have removed. That is the first step that I have done. Remove an element. I have taken variable as top. Now compare for the matching. For example, if whatever that ch is there now. In case if that ch is equal to open. Now read this carefully, and now see carefully, friends. And your top is equal to, let's say, either this or your top is equal to this one, this. Then it says mismatch, return false. So now you'll get the clarity. See here. So this is the ch, so right now I is at index number 2. Right now I is at index number 2. Now your ch is equal to this one. Now your ch is this one. Now actually I'm doing it in a reverse way, friends. If you see here, I'm doing it in a reverse way. If your ch is open, but your top, I think we are doing it a reverse way now. Wait. I think it's confused. Wait. CH is equal to S of I. Okay, if your input is open, you push into the stack. This is clear. Now else, your input is closed one. So which means CH is equal to closed one. Then we have to take an element. Now this will be always st.pop will be always this one, right? So st.pop will be always either this. No, this will be either this or this or this. Your always st.top will be, because in the stack we are pushing only the open brackets. Now what I'm checking, if your input bracket is closed one, right? I mean our input is closed one. Then we are written false. Yes, it is correct only. Next case. In case if your character is, for example, equal to, let's say this is true, and your top is, let's say, your top is either this or your top is equal to if this is open means if like this, then also you have to return false. Next condition, last condition, if character is equal to, let's say, square brackets, and okay, so top is equal to character character open, where I think this bracket is confusing, huh? Wait. If your character is open, you are pushing. Let's say if your character is can be closed one. For example, if your input is, let's say, closed, and your top is equal to, let's say, either this or this, it is a mismatch. Next, your character is equal to, which means your input is this, and when you are popping, for example, if it is equal to either like this or this, then also it is a mismatch. Next, your input is, for example, this one, but your top of the stack is, let's say, opposite of 2, which means either this or this. All these three cases are mismatch. Am I correct? I hope you are getting. Okay, now let's try to write same things here. Let's first, I should have write like this, then now it can be easily converted here. Now if your CH is equal to this, this one, first I'm writing case 1, okay, and your top is equal to, this is true, and your top is equal to, let's say, any one of these two. For example, if your top is equal to, for example, either this or top is equal to either this. If any one is true, okay. Now see carefully, friends. Your input is a closed flower bracket, but your top of the stack is either this or this, which means it is a mismatch, right? So if it is a mismatch, then we should not continue. We have to return false. We have to return false. If this is one case, similarly, what about the next case? I'm copy pasting same thing. So the next case will be, for example, if your input is, let's say, open closed bracket, then see the topmost two things, either this one or this, then also it is a mismatch. In that case also you should return false. Then what is the next case? If your input is, let's say, closed one, if your input is, let's say, closed this one, then what you should supposed to do? Remove the topmost element. So I have stored it here. So where did we have stored? Here we need to store, correct? So here we need to take one variable called as top, and we have to do the pop operation. So top is equal to st.pop, and let's compare the top, right? So top is either, so this completed. Now any one of these three conditions match, so you can stop and return false, friends. But if it is not satisfying any one of these, if it is not satisfying any one of these, then what does it mean? It means this expression is a balanced. But we have to check one thing here. We have to check one thing here, friends. What we need to check? What we need to check here? So here somebody saying we need to change this. Okay. See here, for now this is the basic code, and then you can return true. I hope till here is this clear? Till here we have not yet completed the code. We have not yet completed the code, friends. There is something either, but as of now, basic things are clear now. So what we have done, if our input is open, we have simply pushed it into the stack. If our input is closed, okay, our input is closed, then we are removing an element from a stack, and one by one we are comparing for mismatch. If it is a mismatch, then we are stopping the process. Otherwise, we are simply continuing. But what if, listen carefully my statement, friends, what if our input can start with a closed bracket? Now this is the basic code, but we have to add the edge cases. We have to add the edge cases, right? What if our input can be started with a closed bracket, for example. Now, if my input itself is started with a closed brackets, okay, my input itself is started with a closed bracket. Now check here. Character is equal to closed one. Then of course, if condition will be true, now straight away I am entering into the else case and I am directly doing the pop operation. But no element is present inside that stack now. I hope are you getting? So if your input is started with a closed bracket, then always your stack will be empty. Because if it is open, then only we will push. If it is empty, then what is there to pop? Therefore, directly you applying the pop operation. Before this, we need to check here. What we need to check before this, in case if your stack is empty, in case this stack is empty, then what I should supposed to return? Please comment. What I should supposed to return here, friends? Simple. Directly you can return false, without thinking anything. Right? Without having a second thought, you straight away return false. Because if you take any expression, it should always start from the open bracket. Okay, if any proper valid expression should always start with the open bracket. But if it is starting from a closed bracket, then it means it is not a balanced part. Okay, or then you might be thinking contradictory to this. Let's say if an expression is like this. If expression is like this, then in such case, it is not a balanced one. Because this push operation, so if you take a stack, this will be pushed. For this will be popped off. But from the third element is started again a closed one. By the time stack is empty. Getting na? Therefore, before doing the pop operation, we should always consider whether is it empty or not. Matlab, stack containing some elements or not. In case if my stack is not containing anything, so here itself our story will be over. It won't go further. Okay. Now with this, can I say my question is completed? With this, can I say my question is completed? No, friends. No. One more case is there. One more case is pending that I will tell you. So this is called the edge cases, friends. This actually in the interview, this is how it goes. So one more case is pending. Let us see what is that case. Let us see what is that case. Okay. Now check. So I have taken one expression. Now forget about this expression. Okay. So let's say, what is the output for this expression? Tell me. What is the output for this expression? True. Because stack is empty. So it is true. Now let us check. If it is an open bracket, you simply push inside the stack. Next, if it is a closed bracket, you delete an element and compare for a match. Compare for a match. They both are matching. Then when they both are matching, so it won't enter into any one of these cases. Right? Matching. Next element will be open flower bracket. Open flower bracket means pushed. Next is the closed flower bracket. Closed flower bracket means you delete this element and then compare for the mismatch. They both are matching. Therefore, it will go to the next. Now, next is there any element? No element. By the time our scanning of the expression is completed, does my stack is containing anything? By the time once if I finish my expression, if it is balanced, then my stack is empty, friends. Please note this point. Again, I am repeating. If the expression is balanced, okay? If the expression is balanced, by the time you finish the scanning, stack is becoming empty. Now what I will do? Now I will take one more one, that is one open bracket I will keep now. Now tell me what is that output? Now tell me what is the output? False, right? Okay. Now, by the time first 4 characters are completed, stack will become empty. Now, next, last character will be the open bracket. Now, my open bracket I am keeping here. Now, next, is there anything to check? Nothing. By the time my else is completed. Now, can I say here blindly return true? Can I write blindly return true? No, you should not supposed to write. When you should supposed to write return true, if your stack is empty, once if your scanning is completed, if your stack is empty, then only output will be true. Okay. So here I am going to check. Here I am going to check finally if is empty, which means your stack is empty, return true. Else, return false. Now, does this work? Tell me, friends. Finally, once if all hangama completed, at the end I will check if stack is empty, return true. Otherwise, I will return false. But these three statements, these two statements, can I convert like this? Tell me. These three statements, can I convert it into a ternary operator? Like what I'm saying is, rather than writing like this, return is empty. In case if it is true, then I can write directly return true. Otherwise, I can write directly return false. Can I do? Return is empty. For example, if it is true, straight away return true, straight away return false. Can I write like this, friends? Okay. Can I further betterment this code? Can I do further betterment this code? Yes, we can do, friends. Further betterment we can do here. Now, if you see st, okay, so here this is st dot is empty. St dot is empty. Huh. Now tell me st dot is empty, what it will return output as? Tell me st dot is empty, what it will return as an output? If that stack is empty, it will return true. Otherwise, it will return false. Am I correct? It's a Boolean type. So when it is already returning true or false, then why you are explicitly mentioning true or false? I hope, are you getting? Already stack is empty is giving either true or false. Then why explicitly to mention this true or false? This hangama not required. So this hangama is also not required. You straight away, you can directly return st dot is empty. Story is over. You directly write like this. Got it now, friends? So what we will do, we will remove everything. We'll remove all these three things. Okay. Directly, one single line we can write, that is return st dot is empty. So finally return st dot is empty. Over, stories. Right. So finally, this is the code which will test your given expression is a balanced or not. I hope, are you getting? Again, let me quickly summarize. So let me quickly summarize what we have done here. Let me quickly summarize. Very simple, friends. If it is an open bracket, you add it to the stack. If it is a closed bracket, you take the topmost element from the stack, compare for the matching. If it is mismatch, you can stop. If it is a matching, you can continue. At the end, if it is a properly balanced, you can return st dot is empty. If it is a properly balanced, means it should supposed to return true. That's it, friends. Okay. So now let's take a small break and then we can see some other interesting questions. So next coming is most important, most interesting questions. Right. So now it is 8:27. So we can meet at 8:33. Okay. We'll meet at exactly 8:33. So let's take a small break. Okay. Yeah, we'll continue. Let me start recording. Okay. Now, next we'll start with another question, friends. Most important question, a very famous question called it's a stock scan problem. Okay, stock scan problem, friends. Now listen carefully. What this problem trying to say? So they have taken some particular item or particular stock they have taken, and it's they in a week, let's say of a 7 days, their prices have given in form of an array. So this array is containing prices of some stock for 7 days. Let's say first day, its price is 100 rupees. Next day, its stock price got decreased into 80 rupees, then 60, then 70. Like so, it's ups and down. So we all know the stocks prices will goes up and then down like that, na? Okay. Now they're asking you to find out a span. Like what is meant by span? See what I'm speaking, they'll define in form of a text, right? Okay, so now span meaning is you take any day, for example, if I take, let's say this day or this day 75. Now here it's price is 75 rupees. Now corresponding to this, what is its span is see in the past consecutively. See in the past consecutively how many days its price is less than or equal to that day. Okay, now again I'm repeating, friends. So if this given value is 75, see the past starting one day before. From here, see how many days are consecutively it's less than the price. Now if you take this is 75, now see its previous 60. Yes, it is small. Next it is 70, it is also small. Next it is 60, it is also small. But if you take this is 80, now 80 will be not small compared to 75. Therefore, we cannot take. But after that, if you get any day which is smaller than 75, you won't take it. Why? It should be consecutive, friends. It should be consecutive. Okay. So those who did not understand, I'm repeating one more time. Okay. You take any day. Just before one day. I mean, before that element, see consecutively how many elements its value is less than or equal to this number. So here 60 is also small compared to 75, 70 is also small, 60 is also small compared to 75, but 80 will be not small, 80 will be big compared to 75. Next, if you take any value which is less than 75, for example 70, this we cannot take it because continuity should not disturb. 60 before 80, but after that you get a small value 70, but you should not take this. Consecutively how many days its value is small, those many days we have to take, friends. So how many days for 75 we got? 3 days we got 3 plus including that day also we have to take. Therefore 3 plus 1, its span will be 4, right? Similarly, if you take 85, can you tell me count like this and tell me for this day for price 85 rupees, what is its span? Please type it in the chat. 85. 6, friends. Very good. So it is 6. Why? Because this day, see on the previous day onwards, how many days its price is small? So 1, 2, 3, 4, 5. 5 days its price is small. If you take this is 70, 70 is not small for 85, including 1. Therefore 5 plus 1, 6. Okay. Like that, remaining all we can fill. Now, for every day, minimum one will be there. Pakka. Why? Because including that day, na? So let me call this is the resultant array. Now, for this 100, there is no previous day. Therefore, its value will be always 1. Next, for 80, there is no previous day. So, I mean, previous day value will be small. It is also 1. Now, for 60 also, there is previous day, but it's bigger. Therefore, this is also 1. Now, can you tell me, friends, for 70, how much is the answer? Think careful and tell me. For 70, one value is there. Next, it is bigger. We won't take. If you don't take, the remaining don't take. 60 is small compared to 70, but including that day, therefore 2 we have to take. For this, bigger, therefore don't take. Right? If this is the input, this is the span array output they are expecting, friends. I hope the problem statement is clear. So in your OJ, this is something like a signal capacity problem, right? But they'll change the stories, but the idea is this only. In the past, consecutively, how many days its price is less, those many days plus 1, you need to take it. Financial problem, correct. Signal capacity, like that only. Financial problem, yeah, whatever it is. Now, how can we solve? So one simple brute force approach is, so you can take two loops. So maybe if you take value I, you can start I value from here, because first day, no need to check. Why? Because for the first day, there is no previous day. Therefore, you can directly take its value 1. Now, next you can start from I, from 1 to last element. Then you can take J value 1 day before. 1 day before you take a J value. Now you can compare price of J. For example, price of J is small compared to price of I, then you need to count that day. In case if price of my J, for example, if my I is present here, let us say, then I'm going to start my J value. I'm going to start my J value from here. Okay. I will take one variable and I will count it. If my price of J is small compared to 75, I will take one count variable and I will do the incrementation. Next, if I take another value 70, if 70 is small compared to 75, I'll increment the count. Next, I'll decrement the J. 60 is also small, I will increment. Like that, I will run the J is greater than or equal to 0. Okay. So that finally I can fill that count here. A simple brute force solution, friends. Okay, how this code is looks like, I have already written here. Now see here. So function, it is taking a price array and number of elements, which they have already given in the question. So price array and the number of elements are equal to 7, already given. Price array, number of elements. Okay, I have created one resultant array because I need to store my result here. So I have created a variable called as resultant. Now resultant of 0, because straight away I will set this value 1. Why? There is no previous data. Now the story will start from here. So I starts from 1. So I will start from 1. Okay. Now for everything I will set 1, 1, 1. Why I am setting everything to 1, 1, 1? Because we know that for every day minimum 1. Because including that day, now, apart from if I get any other day, that we need to count it. Correct? Okay. So now J value will start from I minus 1 onwards. And I will compare. If I found any price of J is small, I will simply increment it by 1. I'll increment it by 1 in case if I found it. Otherwise, I'll simply break this. Because if I feel if the day is greater compared to this, then it's previous, I no need to compare. Because continuity should not miss. A simple brute force code, friends. Now, can you help me? What is the time complexity of this approach? What is the time complexity of this approach? 2 loops are there. That too, it is nested loop. N times and N times. So overall time complexity will be order of N square. And I'm not going to in detail of time complexity because it is not much related here, right? N square, friends. But I want to reduce its time complexity. I want to reduce its time complexity. Okay. So, but before I reduce its time complexity, see the left hand side, the code which I have written, same code I have written here. Okay. But see this if condition, common thing is result is equal to result plus 1. But if you see in the condition, I have added one condition here. Same condition I have added here. Then I have removed the else part. Now take 10-15 seconds of time. Tell me this code will work or not. See the left hand side code and right hand side code and observe for some time. Tell me does this code will work or not. I'm just waiting for your responses. Yes, very good, friends. Yes, it will work. See, we haven't done anything here. Simple, what we have done is some beautiful, we have written code in a beautiful way. This is also brute force approach. Okay. And this is also a brute force approach. But we have converted in a little beautiful manner. What that we are doing, in case if your code is, let's say, price of the J will be big compared to price of I, what I need to do? I need to stop the loop. That is what I am doing here. Otherwise, I am incrementing it by plus 1. Now, this condition, rather than keeping inside if else, what if I directly keep here? If this condition true, then only come and increment it. Same thing I wrote here. If this condition will false, it won't come inside. So I have removed this if else and I have kept directly as a condition by adding a logical AND operator. Logical AND operator will give true if this is also true and this is also true. For example, if J is pointing to a valid index, but if this condition fails, then no need to execute it. Right? So I hope you feel the beauty of this right-hand side code. This is also correct only. Both are correct. But some beautifulness we have added here. Okay, but anyhow, time complexity of both approaches will be order of n square only. But we need to reduce, friends. We need to reduce that brute force solution time complexity. First, let's understand why we are getting time as order of n square. I just told that time is n square, but what is the main thing to come as time complexity as n square? Because of some unnecessary comparisons. Now let us see what those unnecessary comparisons are. Now I have drawn one diagram here, you see. For example, if I is pointing to index number 5, then J we are comparing with 60 and 75. After that, 70 and 75 is also comparing. Then 60 and 75 is also comparing. When I is at 5, am I correct? When I is at index number 5, in brute force approach, what we are comparing? P of 4, P of 3, P of 2 versus P of 5. Okay. Then what I found when I is at index number 5, listen my statements from carefully, friends. I'm going to tell one story here. So those are one dialogue I'm going to speak now. Listen the dialogue carefully. In brute force approach, when I is at index number 5, we have compared three days and we found out that all these 3 days are smaller than the 75. And that is how we got its answer as 4, including plus 1 we named. So in brute force approach, it knows that there are 3 days that are smaller than 75 plus 1, 4 we got it. Now, when I is at index number 685, what we are doing in brute force? Again, we are comparing 75, 85, 60, 85, 70, 85, 60, 85, 80, 85. That's how it got as a time complexity n square, friends. Because unnecessary comparisons we are making. Rather than making all these comparisons, okay. For example, if this 75 would have been told to 85, such a way that, listen carefully, like now my comparison is I at 6. It will tell, of course, in brute force 75, first we will compare to 85. Now this 75 would have been told to 85 like that. Let us say, hey 85. So now my 75 is speaking to 85. What it is speaking? Hey 85, I am 75. Okay. I am smaller than you. Of course, I am smaller than you. And there are 3 values who are left side. They are also smaller than me. 75 is saying, hey 85, I am smaller than you. And there are 3 more values that are smaller than me. Then definitely these 3 values are smaller than you. Logically, it is correct now. If I am smaller than you, these 3 values are smaller than me, then definitely these 3 values are also smaller than you. So you don't compare with these 3 values. You directly go and compare with a value which is greater than me. Who is greater than 75? That is 80. So you please ignore these comparisons, which you no need to do it. Because I have already done in my past. I found these 3 are smaller than me. Now I am smaller than you, then definitely these 3 are also smaller than you. So you directly go and compare with a value which is greater than me. Why only greater than me? Because it can't give any guarantee. If a value are smaller than 75, then it can give a guarantee. But if anything is greater than that, it can't give. That is why it is saying that you directly go and compare with 80. So in case if I eliminate these comparisons, somehow I can reduce its time complexity. So is this point is clear for everyone? Is this point is clear? Now let us see how we can eliminate those comparisons. So now finally our problem is brought down to, okay, brought down to eliminating the unnecessary comparisons. How it can be done? If we want to eliminate unnecessary comparisons, okay, this brute force approach has to, it cannot say, because if I want to say this 75 to 85, I should supposed to remember But brute force approach, there is no memory with brute force approach. It can't remember, friends. It can't remember. To remember, we should add some memory to it. So that dimag, we need to add some brain to this brute force approach. So we are adding some memory to this brute force approach. And what memory we are adding? That is stack memory we are adding. Okay. So basically stack is a memory. Okay. Stack, heap, all these are memory, friends. Stack memory, heap memory, right? Okay. Now to this brute force, we have added some memory, and that memory I am calling it as a stack. Stack. Now the main thing is what I should supposed to keep inside my stack. Okay, I have added some memory, but what I need to keep in my memory, that is also important thing. What I need to keep, how many values are smaller than the 75 that I have to keep, so that it remembers and it will tell, hey, I have already stored in my memory, and you can directly take it. Okay, now how it will be done? How it will be done? Okay, now carefully observe, friends. If you understood this now, if you understood this carefully, there are 4 problems you can solve easily. If you understood this carefully, there are 4 problems which you can solve very easily. Just to concentrate. Just to concentrate here. Okay. First. So I will start my loop from here. I will start my loop from here. Why? Because this is no need to do anything. You directly take and keep a value 1 here. Next. Okay. And you put that index, starting index as 0, friends. Why I have to keep 0? Because you should remember that, yes, I have processed this index. For that remembrance purpose, you are storing this 0 here. Okay. Now, let us try to compare 2 things. What you need to compare? One is topmost element versus array of I. These 2 things you need to compare, friends. Now, one more thing here. Inside this stack, basically, we are pushing indices. We are pushing indices. So, learn this problem like a story. Learn this problem like a story. Okay. Now in this story, first you have kept the index number 0 and your loop is starting from index number 1. Okay. Now 2 things are there. One is top of the stack. What is the top of the stack? st dot peak. But if you take st dot peak, you will get index only. But you don't want index. You want a value. If you want to value, you take the price of that array. Price. This versus you need to compare the price of I. These 2 things you need to compare. So in brute force, what we are doing here? So we are taking this 100, we are comparing with 80. Since 100 is not small compared to 80, therefore we are ignoring whatever that value one, that one we are placing here in the resultant array. That is what we are doing now. Okay, so this approach is nothing but brute force plus memory. Memory. Now, since you are comparing these 2, now any 2 values, if you are comparing, 3 cases are possible, friends. What are the 3 cases that are possible? So let me write it here. Just a minute, I'll remove this left side. Okay. 3 cases are possible. Those 3 cases are, this can be equal. Okay. This can be equal, or this can be small, or this can be greater. This can be greater. Apart from, do you get any other cases? Tell me. If you are comparing 2 values, friend, means 3 cases are possible. एक तो equal है, एक तो छोटा है, और एक तो बड़ा है. 3 cases. Okay. Now, which case, what to do? If you know that, story was over. And for what case or for which case, what I need to do? If you know that, then story will be over. Now let us see. Simple common sense point of view, let us think. No data structures, no algorithms, nothing. Simple common sense point of view, let us try to think, friends. That is, first, now let us say, for example, I am at here. Assume that I am at here. Okay. Currently. So brute force approach, J will start from here. Now, ultimately, what you need required, friends, on the left hand side, what are all the small values that I have needed? Those count basically I need. For this left hand side, whatever that values that are smaller than P of I need basically, and those count. So let me write it here. So let me write left side of P of I. Left side of P of I. So let me increase the size. Left side of P of I, all the small values I need. Basically, small values count I need. Am I correct? Tell me, friends. Left side of the P of I, all the smaller values count that I have need. Okay. That is stupid. From the problem only. I'm not doing anything. I'm not doing anything, friends. Okay. Now, here our comparison is always with respect to price of the peak element, topmost element of the stack versus the given element. Topmost element of the versus the price of I. Okay. Now left side, whatever that small values are there that I have wanted. For example, listen my statements carefully. For example, whatever the smaller values that are there, including this. Let me add these two things. Let me add these two things in a single statement, friends. That is, I will remove this. All are equal also I'm going to take. Okay, I have combined those two things into a single one. Now, if any value P of I to its left side means inside stack they will present. Correct? If I need it. For example, if I found a value that is smaller than the given day, I need it. Those values, if I keep it in my stack, assume that I have kept this value 60, just as an example, 60 I have kept. Next, 70 is also I have kept here. Next, 60 is also I have kept again. Then next, this 75 is also assume I have kept here. Then next time when my I is present here, again same comparisons we are doing now, 75, 60, 70, 60. In case if you keep a value, okay, which is smaller or equal to I inside a stack, then double comparison you are doing, which is in fact we are doing in brute force. I hope are you getting now? In brute force, why did we got extra time? Because of these unnecessary comparisons. Now all these three smaller values we have compared with 75. And again, all these small values with 85, again you have compared. Therefore, if you found any small value than that, then don't put it in the stack. You better to remove from the stack. If you keep it in the stack, then again double comparison will happen. Right? So if you found any top of the stack element is small compared to the given price, better to remove from the stack. If you remove, then what will happen? Next time, those comparisons we are able to remove it. If rather than removing, if you keep all small values inside that stack, then next time you are going to do the double comparison, which is in fact not we want. Right? Okay. Now let me see how I am going to implement this code. Right? So I am going to remove all these things, friends. So that I will write everything in a one page only. Okay. So let me move this to the left side. Okay. Now carefully observe how I am writing the code. Okay. So here itself, I will try to write the code. So let's say function fun, it will take the price array and the number of elements. So let me increase the font size, right? These two things it will take as an input array, friends. Now to store that result, I have to create an extra array. Now. So let result is equal to new array. So I have created an extra array because I need to store my result here. This resultant array I have created. After creating my resultant array, let me take one stack also. I have taken one stack also. Okay. Now, first resultant of 0 is equal to, I will add 1. Because I know for the first day, there is no left hand side previous day. So I have added 1. Then I have to push index number 0 to my stack. Because I am adding only indices, friends. I am adding only indices to the stack. So far it is clear. Now I am going to start my loop from index number 1 to last element I++. Now, as of now, any doubts, anyone? As of now, anyone having any doubts? Basic things we have done, nothing else. Basic things only we have done. Okay. Now, here what I said, my dear friends, here, in case if any element from the stack If it is a small compared to that, then don't keep those elements inside the stack. Better to remove those elements. That is what I have said now. Now, as long as if you found these elements inside the stack, you please remove those from the stack. Okay, what I'm doing here, while if price of st dot peak, right, is less than or equal to price of I. If this condition would be true, then what I said, friends, you remove elements from a stack. Simply st dot pop. Okay, is this clear? Same thing. What I said in form of a story, I convert it into a code. But one danger is there with this line. Some danger is there with this line, friends. What is the danger? If you remember in my previous question also, here also, directly rather than popping, I am checking it is empty or not. Right? Therefore, same thing also we need to check here. Rather than popping blindly, you first please check whether stack is empty or not. Which means if st dot is empty, stack is not empty, or you can write st dot size is greater than or equal to 0 also. Both are correct only. Okay. If your stack is not empty and if this condition true, then you can remove elements from a stack. I have no problem. So what is the line number 2 inside that function? This is simple. I have declared a stack. This is the code for I have declared an empty stack. Okay. This is done, friends. Now let's try to apply same thing here. Now let's try to apply same thing. Right? Okay. So first of all, we have created a resultant array. We have created, first of all, a resultant array. We have created of the size of n, whatever the given size we have created. Right? So let me name it as a resultant res. Okay. So resultant of 0 is equal to 1. First today I have kept its value as 1. After that, I have pushed 0 also inside to the stack. Now I am starting I is equal to 1. So I am starting my loop from 1. Okay. Now what are all the things I am comparing, friends? Topmost element with respect to stack. So p of st dot peak. What is st dot peak right now? 0, friends. So I am comparing price of 0. In case if it is less than or equal to price of I, which is p of 1. Okay. Is this true? Is 100 is small compared to 80? No. Then false. This condition will not get executed, friends. When this condition will not get executed, okay. Now you need to go to the next element. But before I go to the next element, I have to add some result now here. So normally what that result is nothing but 1. But how did you got that 1? In stack, it will remember. What it will remember? Right? There is no value which is smaller than you, right? There is no value. I did not find it out. If I would have been find it, I would have been deleted from the stack. But I did not find anything. Then if I did not find, then how can I know? How can I know this thing? So your day is 1 and my day is 0. Between there is nothing. Therefore, from your day, you try to remove my day, which is present. You will get the data. So it is saying resultant of, after removing this, simply resultant of I is equal to what you need to give, friends? I minus whatever that I minus st dot peak. You need to keep it here. See, again, code is not completely over. Step by step, I am building the concept. Once it is done, next what we need to do now, friends? So you simply push that index number I to the stack. You simply push that index number I into the stack. Okay. So that I'll know that yes, I have processed this day. So I am going to push it to the 1 here. So next time, now my I will be pointing at next time. Now my I will be pointing at 60. Okay. Now see the story, friends. Now compare 80. Why 80? Because top of the stack is 1 now. Now is my 80 small compared to 60? If yes, I will remove. But 80 is not small. So 2 minus 1, that is 1. I am going to store it here. Okay, then I will add this index number 2. Okay, and then I will increment my I. Again, same story. Is my 60, next topmost element is 2, friends. 2 is nothing but a 60. Is 60 small compared to 30? Yes. So I will remove. Why I am removing? Because next time if anything comes, then those unnecessary comparisons we cannot do. That is why I'm removing now only. Okay. Next. element number 1. Is 80 is small compared to 70? No. Then this while loop condition will fail. Now resultant of I is equal to 3 minus 1. What does it mean? What does 3 minus 1? Meanwhile, whatever the days are there, that we will, from this subtraction, we will get. So 3 minus 1, which is nothing but a 2. In fact, we also need 2 only, right? Then you push this 3 here. Okay. Next, I will be incremented. Now, here you take a pass and try to see, friends. Next time when it is 60, I'm not, if I compare 70, the next 60 I won't compare. Why? Because 2 is not there in the stack. That's why I don't compare. Now observe. So 70 is my 70 is small compared to 60? No. Right? This while loop condition will fail. Then 4, okay, minus 3, which is nothing but 1. Okay, and I will add this 4 also into the stack. Right? So next, I will be incremented. Now again, same story will happen. What that story? First 60, which is nothing but 4. 60, it is small, so delete from a stack. Next 70. 70 is also small, therefore delete. In brute force approach, we should compare next is 60. But now what it is doing, it is directly comparing with 80. See how the beauty. Okay, so is 80 small? No. Then while loop will fail. So 5 minus 1, 4 will be kept here. Then next 5 will be pushed inside to the stack. So these are gone. These are gone. Now next you are adding 5 to here. The next I will be incremented. Now you will get complete understanding, friends. Now you will get complete understanding, and that beauty you will get to know. That beauty is normally top of the stack 5. 75 is small compared to 85. Yes, then I will pop. After that, if you check, it is saying, hey, you directly go and comparing it with the 80. Why it is not saying these comparisons? That is the beauty of the stack. It is said in my previous iteration, I already counted that and I remembered that. How it remembered? Because it is a memory. Okay, in my previous iteration, I came to know 75 said come, there are 3 days are there. And since 75 is small, therefore I know already these are small. Therefore, directly I'm comparing it with 80. So it's self-understood. This is that 1 small. So we will remove this value. So directly 6 minus 0, 6 we are going to keep it here. Okay, so with this story is over, and we can directly return that resultant array, friends. Return that resultant array. I hope till here is this clear. Till here, is it clear, friends? Simple, with common sense, I'm taking up the concept as. With the common sense, I'm taking the concept. But there is a problem with this code. There is small problem is there with this code, friends. What is that small problem? What is that small problem that is present here? For this example, it is working fine. For this example, it is working fine. I have no issue with that. But the problem is, assume there is an example for every element if this while loop is true. Let us say for every element, this while loop is true. Then all the elements are going to get deleted from the stack. By the time if stack becomes empty, you are without checking, you are directly accessing. Then in such case, don't you think it will give underflow error? Assume all elements, this condition is true, and all elements are also getting deleted. After that, you are accessing this element. What you will get? Nothing. Therefore, before accessing this also, you need to check. What you need to check? In case if your stack is not empty, then only you access this condition. If your stack is, then only you can access this condition. Otherwise, you should not supposed to do this. If stack is not empty, then only you take. But if what if my stack is empty, what to do? If my stack is empty, what to do? Else, I need to keep something in my resultant of 5. I have to keep something else. In such case, what I need to do? This is your homework. I have to fill some value here. What value that I supposed to fill is a homework for you. You take some examples. So I want you people to work on, right? You take some examples and you try to fill what exactly you have to keep. So what exactly you have to keep is a homework. Okay. Now, these 2 things, I can combine it into a single statement, friends. How? Like a ternary operator. So I can take a ternary operator. So if stack is not empty, then I can fill this, right? So I'll remove this maybe, or else I'll write it here only. So resultant of I is equal to, okay, what I'm checking. If my stack is not empty, that is true, then I will keep I minus st dot pick. If that is false, that is your homework. If that is false, what to write is your homework. So you try to work out, you will get some pattern. With that pattern, you can able to fill that. Okay. So this recording will be available on the YouTube. So you can get this recording on the YouTube also. So friends, here what I wrote, if your stack is not empty, then this you understood. Okay, no problem here. But what if the stack is empty? What you will get exactly here? Okay. So this is your homework. What exactly you need to place is your homework. Homework. Right? Is this clear for everyone? What you need to place, you homework. Okay. So I hope everyone understood. Okay, somebody saying I plus 1. Yeah. So try to take some examples. So where for every take an example in such a way that stack will becomes empty. If that is empty, what to keep? What to keep? Okay. Cool. So shall we go to next question or do you need a break? Now, based on if you understood this, I'm telling you now you can able to solve 4 classes, 4 problems. 4 problems you can just like that you can solve 4 problems. I will make that happen. Okay. So I think someone asking a break. Even I too require some break. Okay. So we will short break only. Let's meet at 9:15. Try to observe this code. So we'll meet at 9:15. Okay. Yeah, we'll continue. So let me started recording. Okay, so friends, now based on this model of questions, we will see some other questions which will follow exactly similar to this question. Okay, but you don't know that they will follow like this. Now you will realize those questions are. First question is, so this is completed. Yeah. So the first question is nearest smaller element to its left. Okay, so what does it mean? See here. This is the given input array. Now for every element, you see it on its left hand side. It's left hand side. Okay. For every element, check on its left hand side. You need to find a smaller element. That too, it should be nearest, which means close in terms of a distance. Like for example, for the first element. So here, if I call this is as a resultant array. Now for this element, in fact, there is nothing on its left hand side. So let me take it is as a -1. Okay. Now for this element on its left side, there is only one element, and that too, that element is small. So I'm going to take that element. Next element will be 4. See on its left hand side, there are 2 elements are there. Among this, which one is small? One will be small. Therefore, I'm going to take that element. Next element is 10. Now all to its left side of 10, total 3 elements are there. All the 3 elements are smaller only compared to 10. But who is closer? 4 is closer to 10 in terms of the distance. Okay. So I'm going to take 4. Next 2. For this element, see on its left hand side, how many? 4 elements are there. Out of 4, 1 element is small, and that element is nothing but 1. Next element will be 5. Now 5, what will be the output? Tell me. For 5, what will be the output? See on the left side, who is small? That too, it should be closer. For 5, 2 is also small, 1 is also small, but 2 is more closer compared to 1. Therefore, we need to write 2. So this is the problem statement, friends. I hope is this clear? Problem statement is clear. Okay. Now, say one more example, let us take. Okay. And let me quickly fill this. First element by default, you can take it as -1. Without thinking anything, you can directly take it as -1. Why? We need left side. We need left side. Okay. For first element, there is nothing on the left hand side. So straight away, you can keep -1. This element. Now think and tell me what is the output for this element. -1. Very good. Why? Left side, one element is there. That too, that element is not small. If that is not small, we will take -1. Next element will be 4. Now for this, please start typing. Okay, 2. Next element, 6. This is also 2. No, not 2. It will be 4 because 6. 4 is also small, 2 is also small, but 4 will be closer, just 1 step away. Whereas 2 is 2 steps away. So 4 I am going to take. What about 9? 6. What about 3? 2. What about 8? 3. What about 11? 8. So if this is the input and this is the output, friends. Okay, I hope you can do the brute force solution. That is order of n square. I'm not going to speak this. You take care of brute force solution. Let me tell you stack solution. Let me tell you the stack solution. Okay. So I have taken one stack here. So as usual, so let me write a code on the left side, and or else I'll take the previous code only. So let me write a separate code. So let's say function fun. Listen carefully, friends. So function fun. So it will take input array, comma number of elements. So I have to take a resultant array. So let result is equal to new array of the size n. Afterwards, I'm going to take one empty stack. Okay, again, its syntax will vary from programming language to program. Okay, after taking stack, so straight away I will take resultant of 0 is equal to -1 without having a second thought. Why? First element, there is nothing on the left hand side, so straight away I will take -5. Next, so to the stack, again I'll push 0 because so that I'll remember, okay, I have compared or I have processed. For that purpose, I will store 0 inside to the stack. Now the story will start from first element onwards. Same which we have done previously only. For I is equal to 1, I less than n, I plus plus. Okay. Now listen carefully, friends. Now listen carefully. Okay. You take any element. Now you are going to compare two things. One is, let me type this one also. So basically, you are going to compare two things. That is, array of st.peak versus array of I. Am I correct? Of course, top of the element of the stack. In the same previous problem also, we have done same thing. We have taken the topmost element of the stack and we have compared it with the array of I. Again, total 3 cases are possible. 3 cases are possible. Okay, but now you need to know what I need to keep in the stack and what I need to delete from the stack. If you know that, story was over. Many people will buy heart this. Many people will buy heart this, friends. So because I have seen the students are by hearting these codes. Like how many elements, how many questions we do by heart? Tell me. Learn the concept. Okay. Now again, any element you see, any element to its left side, if you see a smaller element that we required, friends, that we required, then we don't delete it from the stack. Listen carefully. For example, okay. So first element for here, 0 you have pushed into the stack. See carefully. So I will be start from here. Index number 0, we have pushed it. Now, this is topmost element of the stack. If you see this element, this element is big or small compared to array of I. So here, top of the stack, that is ARR of st.peak, which is 7. Okay. And what about array of I? What about array of I, which is 2? Now tell me, is this 7 is small or big? Big. So this is big. Is that place any importance to us? Tell me. No use. Correct? No use. If no use, remove from the stack. If there is no use, then remove from the stack. Story is over. I know you might not feel is it true or not, but story was over, friends. While is empty, stack should not be empty. Okay, and if you found a value ARR of st.peak is big compared to array of I, with that there is no use. No use. You simply delete from the stack. st.pop. After deletion is completed, resultant of I is equal to, if stack is not empty, for example, if stack is not empty, okay, if stack is not empty, then you keep ARR of st.pop, st.peak. Otherwise, you take -1. And inside that stack, you push that index I. Over, story. You return resultant array. That's it, friends. Okay, sir, what if it equal, we will keep. If it is equal, we will take it, friends. If it is equal, we will take it. Okay, so let me put it in a further more way. I mean, in much better way, I will tell you. if you found any element that is greater than array of I, there is no use with that element. So delete that element from the stack. Simple. Now you check what is the first element, 0, that you have kept. Now 7 will be big compared to array of I. There is no use with that element. Therefore, I am going to remove that element. After removing, while loop will become false because stack is not empty. Right? So I am checking here. Is my stack is not empty? No, my stack is empty here. Then I'm going to keep -1 in the resultant of I. So I have kept -1 here. Next, I am going to push that index number I, which is index number 1. I am going to push into the stack. So next time I will be pointing here. Okay. Now check this carefully, friends. Now check this carefully. Next element is top of the stack is 2. Next element is top of the stack is 2. Now if you apply the same, so we have pushed 2 here. So 1 minute. Now 0 is gone, right? So we have kept index number 1. Now I is pointing at index number 2. So again, now 2 is small or big compared to 4? Tell me, what is the ARR of st.peak? What is the ARR of st.peak? 2. Right? Is it greater than the ARR of I? Is this true? No. Then while loop condition will not get executed. Now I am checking. Resultant of I is equal to is stack is empty. If that is empty, we will keep that element as it is. But my stack is not empty now. What this condition is saying is stack is not empty. True, stack is not empty. Then what we keep ARR of st.peak will go ARR of 1 and we're going to keep 2 here. Are you getting? It takes some time to grasp. It takes some time to grasp. Same. Resultant of I is equal to 2 only we are keeping now. Array, see, inside the stack we are storing the indices. Inside that stack we are storing the indices, friends. Therefore, if you want to get a value, then go to index number 1, take that value and put that value here. So remaining, can you able to do the dry run? Remaining part. Similarly, can you able to do the dry run now? Okay. Story was over, this question. This is nearest smaller element on the left side. Okay. Same way, nearest smaller element on the right side, can you able to do that? We have seen nearest smaller element on the left. Now what I need to do? Nearest smaller element on the right. Okay, I'll take one example and I'll tell you. Maybe let's take this example. Let us take this example. Okay. Now I want to find out nearest smaller element on the right side. So friends, always remember, when they are asking on the left means start filling from 0 to n-1. That is from left to right. When they are asking on left. But what if they ask nearest smaller element on the right? So let me type it here. Nearest smaller element on the right. Right. So when they both are smaller only, that is left, this is right. So when they are asking on the right, can I blindly keep -1 here? Tell me, without having my second thought. Of course, common sense only this is. Why? There is no right side element for that. Okay, now let's start filling this element onwards. Now for 8, what is the output it should come? See on the right hand side, if you found any smaller element, you keep, but there is nothing. So -1. What about this element 3? See on the right side, smaller element I need, nothing, -1. For the element 9, 3 is smaller, 8 is small, but who is closer? 3 is closer, therefore 3. Next, for 6, only one element is smaller, so straight away you take that element. What about 4? 6, I think only 3, so directly you can take 3. Next for the 2, I don't think so any element. So minus 1. For 7, 2 is small, 4 is small, 6 is small, 3 is small. But who is closer? 2 is closer. 2. So you take the same code, small modification you need to do. Can you be able to do that? Small modification you have to do here. Rest as it is, same only. So do the small modification to this code, you will get that result. So do the small modification. You need to reverse that loop. Very good, very good. One student told that just to reverse that loop, story was over. Rather than resultant of 0, if n is equal to 8, okay, rather than resultant of 0, you need to write res of n minus 1 is equal to minus 1, okay, and inside that 0, you can keep n minus 1 and you start loop from n minus 2. Simple. And reverse loop as it is. No need to change anything. Concept remains same. Whether it is left to right or it is right to left, concept will remain same. And smaller 2 things we have seen. Nearest smaller on left we have seen, on right we have seen. Can you guess what is the next question? Smaller we have seen on the left and we have right also we have seen. Of course, next is greater. Same strategy I'll apply there also. Same strategy I'll apply there also, that is greater. Nearest smaller, nearest greater element, previously smaller is done. That to smaller left we have seen. Now in greater, we will see the right one, okay? Because so that I know I have covered both left and right also, right? Now this question we will check. Nearest greater element to its right we will see, friends, okay? Right means start filling from right to left. So this value blindly I can take minus 1 without having any thought. This element, can you help me? What is that answer? 2, 5. Very good. I think you are following. I hope everyone is giving very good answers. 10. Very good. Minus 1. I'm very happy. All are giving correct answers. For 4 friends, 10. Very good. For 6, right side, who is greater? 10. Okay. For 1, who is greater? All are greater only, but who is close? I want. 6 is close. I want. Okay. Very good. Now how we can implement this? How we can implement this? Simple, friends. So let me put it here. So I will here itself. I'll write code in front of you only. These are bacha problems, okay? But only thing is you need to learn it in a proper way. Proper way, if you learn, nothing else. Are easy questions only. So function fun, it will take input array comma number of n. Story will be same. First you take a resultant array size of n, and you take one empty stack, okay? If you remember, n is equal to 6 and you kept to last but one element as minus 1, last element. So therefore, so what you need to write here, resultant of n minus 1 is equal to minus 1. Why? Because, see friends, why? Because indices are starting from 0. Indices are starting from 0, friends. That's why res of n minus 1 is equal to minus 1. Okay. Inside that stack, what you need to push? 5 you need to push. Because you are processing from right to left, na? But 5 I cannot write. I have to write n minus 1. Okay. Now loop I need to reverse. Why I need to reverse? Because it is a greater one. So for I is equal to n minus 2 onwards, I have to start. Because this element is not required. Because ho gaya na, iska minus 1. We have to start from here. Right? Okay. I is greater than or equal to 0. Okay. I minus minus. Okay. Inside while loop, what I need to write? So think as if it is a fresh problem. Think as if it is a fresh problem. Forget about what we have learned in the previous problems. Think as if it is a fresh problem and try to write a code. Okay. Okay. We'll also think like that only. Because in an interview, they will ask like that only, friends. Okay. So what we need to compare? We need to compare array of st.peak versus st.peak versus we have to compare array of y. Okay. We need a greater element. So to this element, if anything is smaller on the stack, is there any use? Tell me. Any element is smaller, is there any use? No use. Then delete those elements. You found any element that is greater, smaller compared to that, you delete it. because with this there is no use. So let me do right here. Okay. This is a stack. Okay. This is a stack. So I will be, let's say I is pointing at here. First time I is pointing at here. Okay. And this index number we have already pushed into the stack. Now let's compare this 5 versus this 2. Now compare it to array of I. If you take the array of I, okay, if you found a value, now this is array of I, and let's say this is array of st.peak. Okay, I'm writing roughly. Now, as of now, array of my I is 2. My array of st.peak is 5. Okay. Now, if you see 2 compared to 5, it is less, which means this is bigger. Bigger means keep it in the stack. But when should I remove? In case if my array of I will be, let us say, bigger compared to array of st.peak, no use, I'll simply remove. Okay, I'll write same thing here. While st is empty, while stack is not empty. Okay, and and array of I, okay, array only we have taken. If let us say that is bigger compared to array of st.peak, then there is no use with that element, which means if my the element which you stored inside the stack is small compared to the array of I, reverse way you have to think, then there is no use with that element. Then no use, then delete that element, st.pop. That is not the case, then happily resultant of I is equal to, okay. So in case if stack is not empty, then directly take that element. In case stack is not empty, okay, you take the array of st.peak. Otherwise, you take -1, okay, and you push I inside to the stack. Push I inside to the stack. Over, story is okay. Return resultant. That's it. So I thought this problem as a fresh problem, and from the concept I have derived the code. From the concept I derived the code. So somebody asking, sir, why? Sir, why we are not taking equal numbers? Equal numbers actually is an exception. So if for example, let us say, friends, 4, let's say here 4 is there, then the answer will become 4. Or in case, again, they will mention in the question, for example, if they told there are no duplicates, you take this code. If duplicates are there, then you can keep less than or equal to also. That is problem to problem, it will vary. In case in the question specifically if they mention, then take care about the code. Only thing is the symbol will be added, that's it. One symbol is added, friends, that's it. Rest everything will remain same. Okay, now same thing, nearest to greater, left can you able to do? Nearest to greater, left can you able to do? Same only, like same code as it is, reverse loop you need to do. Left is easy than right. No, nothing like that, all are same only. This is reverse loop only, that's it. Right? Is this clear, friends? Okay. Now, one problem we have seen, that is stack span problem. The first problem that we have seen is stack span problem. For that problem, okay, we have covered nearest smaller element on the left, nearest smaller element on the right. Similarly, nearest greater element on the left, nearest greater element on the right. One problem is equivalent to 4 problems with a small modification. If you learn one problem conceptually, okay. So how much time that we have taken for all the 4 problems? Maximum 5 minutes per question, that's it. Not more than that. So in your lifetime, you should not forget these solutions. Every question, the syntax will be proper idea, friends. For loop is there, inside while loop is there. For loop inside while loop. This is the structure. And from the problem, we have derived everything. Is this clear? Now, I hope, are you feeling, is it easy? Crystal clear. Very good. Very good. See, I have seen in many YouTube, they are struggling a lot to explain these concepts. If you understood what is the root of that problem, right, then easy, friends. Now, tomorrow they will do some modification to this question in interviews. They're asking next grade, some variation they can ask, but the underlying concept will remain same only, stacks. right? So underlying the concept doesn't change, friends. That is the stacks, right? So can you go to next question? I hope you, or should I stop, or do you want more questions? I don't know, it becomes too much, or so please do comment. Right. So one more question I'll explain and we'll stop. Okay. So one last question I'll take. This question. Again, I mean, this very important question, friends. This I will take and I'll stop. Okay. Last question. So this question is asked in Google, Microsoft, so many companies. This question is asked. Very easy question. Very easy question. Okay. Now listen carefully. Carefully this question. The problem name is, or let me first show you what are all the companies this question have asked. Okay. So we'll go here. I'll show first. Maximum rectangle histogram area. So if I go to Geeks for Geeks, the practice tag, see Amazon, Facebook, Microsoft, Paytm, very good companies are asked this question, right? So now let's understand this question. Okay, I'll explain what is histogram, all this. I'll explain. Okay, so the input to this question is an array. Input to this question is an array is given to us and number of elements are given. Number of elements are given. Okay. Output, what they are expecting is, so first you need to visualize this question, friends. So I'll go to the next slide and I'll visualize it. So this is the given input array. Na? So 1 minute. So this input array, I will put it here. This input array, you need to visualize like this. So first element is 6, which means height of 6. So this height is 6. Next element will be 2, which means this height is only 2. Next element will be 5. This height is 5. Next is 4, like that. So if you see, so this is having a height of 6 meters. Let us use 6 meters. Then this is only height 2. This is only height 4, like that. Okay. Now after taking that, now you need to create. These are called as a histograms, friends. See, like have you studied the data interpretation for competitive exams? For competitive banking exams, they will ask pie charts, data interpretation there. So this is nothing like that, histogram. Okay. Now for every element, I hope you know rectangle. So in rectangle, opposite sides are equal. That is the definition of rectangle. Na? So rectangle, this is a rectangle. So this is length and this is breadth or height. Or height. Okay. So this is length and this is breadth. So what is the formula of a rectangle? So area of a rectangle is length into breadth. We know already. Okay. This is the formula, right? Okay. Now histograms, we have visualized it. Now for every element, if you take array of 3, its value is 4. Okay. And that 4 is nothing but a breadth. You need to find out its length, friends, so that you will get an area for array of 3. So array of 3 is equal to 4. Now you need to calculate area for array of 3. Now for array of 3, if you want to find out the area, you require length and you require a breadth. Breadth is already given it in the question. Now you have to find out its length. Its length you have to find out. To find out that length, what you need to do is, for this element, go right side as long as you want till you find an element that is smaller than this. Now, from here, I am going its right side as long as I want. But you have to stop if you find an element that is smaller than this. Now, this element is 4. On right hand side, I found an element which is smaller than this. This I will store it in a variable called as right. Okay. Similarly, left side also I will go as long as I want till you find its next smaller element. Yes, next smaller element I found it here. That is index number 2. Sorry, index number 1. This I am going to call it as a left. Left. Now, why I am taking this is left and why I am taking it is right is, first of all, I need to form a rectangle. Okay, my rectangle is formed here. So I am drawing it in a black color. This is my rectangle. Now tell me, friends, its breadth we know already, which is given in the question and which is nothing but a 4. What about its length? What about its length? What about its breadth is anyhow already given it in the question, which is nothing but 4. But what about its length? Think careful and tell me. From here, it is rectangle. Na? Its length is nothing but 3. Its length is nothing but 3. But how did I got that 3? How did I got that 3? Can anyone tell me? To get this 3, okay, can I write 5 minus 1 minus 1? Can I write like that? Which is nothing but can I do this? To get a length, it is stopped at 5. It is stopped at 1. 5 minus 1 minus 1, which is 3 length. Okay, so what is its length area? Which is 12 units. Like that, for every element, you should supposed to find out. Like that, for every element, you should supposed to find out. Okay, I'll take one more example, maybe. What example we'll take? See, this is 0. Here, one edge case you need to remember, friends. 0 to its left, it is minus 1. And 6 after that, it is 7. And number of elements are nothing but 7. Okay. So let's take array of 5. Array of 5, its value is nothing but 1. Now I want to find out its area. Area of array of 5. So I required length into breadth. Breadth is anyhow given in the question, which is nothing but 1. But I want to find out its length. To find out its length, go right side as long as you want till you find next any smaller. You did not find, so you stop here. Similarly, go left side as long as you want, but I did not find any small value. So I will stop it here, here and here. Okay. Now this is nothing but its area. So its area, what is its length, friends? Tell me. What is its length? Which is nothing but 7, right? 7, right? Okay. So how did I got that 7? So this I have to assume minus 1 because before 0, it is minus 1 only. So which is nothing but left, which is nothing but right. Now tell me, if I apply this formula, can I get this answer? Can I get this answer? Yes, of course. Length is nothing but 7 minus of minus plus 1 and another minus 1. So cancel. So 7. So 7 into 1. Its area is 7 only. For array of 3, you got a area as 12 units. This you got it as 7 units. Like that, for every element you have to find out. Tell me at the end what is that maximum one. Tell me at the end what is that maximum one. Okay. I hope the problem statement is clear for everyone. Okay, very good. And somebody said it's a good question. Yes, this is asked in Google, friends. This question is asked in Google, Microsoft. Okay, many companies. Okay, now, so for every element, okay, see on the right hand side who is the greater. No, smaller. See on the left side again who is the smaller. Left side who is the smaller, right side who is the smaller. Don't you think have you solved this question? Tell me. I will go to the nearest smaller element on its right. Similarly, I will find out who is the nearest smaller element on its left. And I will apply this formula. And I will multiply with its breadth. And among all I will find out its maximum. So can you be able to do that? It's a little tougher one. But if you put all things in a properized way, you will do it, friends. If you put, first of all, you need to do, for every element, you have to take extra 2 arrays. Extra 2 arrays you need to take. For every element, what is its left smaller, what is its right smaller, you need to store. That's it. In 2 different arrays. One for left and one for right. Then apply this formula. Then you'll get the maximum area. Okay. So take it as a homework. Okay. Take it as a homework. You can pick it from either lead code or I'll see if it is Noja. I will try to give it to you, but you can take it from either outside and try this question. It's a good question where it covers all the concepts. All the concepts as of now you have learned, it will test this question, right? So you please solve it, friends. Okay. So that's it for this night. So same concepts only. That's it for night. Okay. So thank you for everyone. Okay. Thank you so much. Thanks. We'll meet in the again next master class with some other topic. I'll tell you. We'll come up with other. Okay. Thanks for everyone. I'll stop the recording. Next screen. Okay. So area problem. Yeah, I will add it to the. Yeah. Good night. Good night, everyone. Take care and practice the questions. Right. So that is most important. Sir, next master class. Recursion is already there, na? Recursion is already there in our YouTube. You can check. In Masai YouTube channel, it is there. Right. Yeah. So after this recording will be available in the YouTube. So you can DP. Yeah. Next we'll try DP. Okay. So yeah. I think Srishti, are you there? You can.
Yes, Venu, we can end.
Okay, thanks. Yeah, thanks everyone. Yeah. So sorry.
Oh, yeah.
No, are you speaking something?
No, actually it's YouTube live.
Oh, okay, cool. So thanks everyone. So yeah, you can get the notes on LMS. We will add these notes to the LMS. You can find it there, right? And some other extra problems also I'll add it to that. You can find it out there. Okay. So thank you all.